What you are watching is an artificial neural network that is learning something. Now what it is learning, I will get into that later. But first, let me explain what an artificial neural network is. This is kind of what a neural network looks like. Alright, each of those circles represents a neuron. Now, those lines connecting the dots actually are called weights, which are these values that change the output based on the input. So you feed in some inputs and then you get an output. And what you're trying to do is you're trying to find the perfect weights that will give you the right outputs. This neural network is learning something called logic gates. Now, if you're not familiar with logic gates, let me just give you a quick explanation.
You can think of logic gates as hands, or two switches that open a gate, which you could represent with your hands, which I'll do right now. Anyways, so think of this as your gate, opening, closing, and think of this as your switch. This means on, this means off. This means on, this means off. Both on, both off, right? Those are the only configurations you could possibly have with that. Now, based on which gate you're passing those switches into, will determine which gate will open. So for the AND gate will only open if both of them are turned on, right? On the OFF gate, it'll only open when they're turned off, right? On the OR gate, they will turn on if this is open, and this is open. But on the XOR gate, this is not open, but this is open. Anyways, that's logic gates for you. So this neural network learns the logic gates. It says which one would be turned on based on the two inputs. So which gates will it turn on? And it starts off not knowing how to do this, and it learns.
So I decided to test the network before training it. The inputs are 1 and 1. In binary, 1 means on, 0 means off. And if you pass these through the network, you get the outputs, which are the other black boxes, and next to the outputs is the desired outputs, or the correct outputs. If you look at the outputs versus the desired outputs, you'll be able to tell that they're pretty different. Now I'm going to show you every single configuration of inputs and show you the outputs real quick. Alright, so now we're going to train the net. Training will commence in 5, 4, 3, 2, 1. In case you've already forgot, this is what the weights looked like before they were changed, and now this is what they look like. And you may also be wondering, what is that blue number that keeps counting down on the top left corner? That number is called the error. Well, what is an error? An error basically just tells you how bad you're doing, and as you can tell, that error is decreasing, so it's doing better as it trains more and more.
You can think of an error as something like a bowl, right? Now why a bowl? Well, a bowl has a minimum, has a bottom, rock bottom right here. Now you're trying to get to minimum, because when you get to minimum, that means you're always correct. Because when your error is 0, that means you're always correct. Or think of it as, if your error is 1%, that means you're 1% incorrect and 99% correct. So, and if you're up here, very high error, you can probably be as well as 0% correct and 100% incorrect. So basically, what you have your variables do is slide to the bottom of this bowl by changing their values in a way that it'll minimize the error.
Now you might be asking yourself, well, how do the variables know how to slide down the bowl? I don't see how they can just do that. Do they have a mind of their own? Is it magic? Is it voodoo? No. It's math.
Now, for those of you who are not familiar with multivariate calculus, I will explain this in a way that you will kind of most likely sort of understand. Alright, so take this chord for example. Now, how does this chord change when I move my hands? Right? See, the bend is fluctuating. Now, the length of the bend, see, the length of this right here, this little loop or whatever you call it, this little hump. The length of this hump changes when I move my hands, right? The length as in the vertical length. So the length of this lump will change as I move my hands. Now, what you're doing is you're trying to see, okay, how does this lump change when I move my hands closer to each other? That can be a variable. So imagine that, but with this neural network. Now you saw those things that were moving up and down, those weights. Those things are variables, and they change the error. So now you're saying, how does the error change when I move those things up and down? So it turns out that all you need to do is subtract each weight by the change, and it'll lead you down to 0.
Okay, now that we've trained the net, you can see that all the outputs match the desired outputs when you feed in the inputs. Now, what would happen if I decided to switch the desired outputs for the inverse of the desired outputs? So basically what this means is for every time it's expecting a 1, it's now expecting a 0. And for every expected 0, it'll be now expecting a 1. So let's see how it fares with this. What you just witnessed was the neural network adapting to the change in expectations. So, yeah. This is the error right before I switched the expectations, and as you can see, it's pretty dang low. This is the error right after I switched the expectations. As you can see, it's significantly larger than 0.019. I'm just saying. So now let's just watch it converge. What you just witnessed was a neural network adapting to change in expectations. Now this is kind of like our brains, because our brains can adapt to changes as well. The neural networks can change their connections to adapt to changes in the environment. So it's kind of the same principle. Matter of fact, you can think of the brain as just one gigantic neural network. If your mind has not been blown by this, then you need Jesus, alright? Spray some holy water on you, because I don't understand what will blow your mind if this doesn't blow your mind, alright? Alright, y'alls. I have not slept in 30 hours, so I'm gonna go sleep. I hope you enjoyed, and I hope you learned a thing or two from this video, and I really do hope your mind was blown like my mind was blown. Alright, catch you laters.